Welcome. Today we follow a single question on its journey through ChatGPT, and by the end, you will be able to picture exactly how it works. You type something, press enter, and a moment later words appear, one at a time. That short pause is not the model thinking the way you do. It is a fixed pipeline running, then running again, very fast. Let's slow it down 1,000 times and watch. Let's start with our question. Why is the sky blue? To you, that sentence has meaning. To the machine, it begins as nothing at all. It is just a string of characters, letters, spaces, and a question mark sitting in a row. No grammar yet, no intent. Everything that follows is the model building meaning out of that raw text. The first real step is called tokenization. The text is carved into chunks called tokens. Common words usually stay whole, so why, is, the, sky, and blue each become a single token. But rarer words get split into pieces. The word tokenization, for example, breaks into token and isation. A rough rule of thumb in English is about 4 characters per token, so a token is often a word piece, not always a full word. Keep that in mind. Where do these tokens come from? They live in a fixed list called the vocabulary. Think of it like a giant dictionary of every chunk the model knows. For a model like this, that list holds on the order of 100,000 entries. Every token in it has its own number, a simple integer ID. So Y might be 3,838. Sky might be 6,542. The model never sees words. It sees these ID numbers. But an ID number on its own is meaningless. 3,000 has nothing to do with the sky. So each ID is looked up in a huge table called the embedding table. There, the ID is swapped for a vector, a long list of numbers, often hundreds or even thousands of them. You can picture that vector as a position in a vast space of meaning. Tokens with similar meanings sit close together. King, queen, and prince cluster in one neighborhood. Bicycle sits far away. There is one problem. The model processes all the tokens at once, not strictly left to right. So on its own, it would not know which word came first. To fix that, a position signal is added to each vector. It is like stamping each token with its place in line. First, second, third. Now even 2 identical words can be told apart by where they sit. Order is part of the meaning, and the model needs it. Now the real work begins. These vectors pass through a stack of transformer layers. A layer is just one processing stage, and the model has many of them, one after another. At each layer, the vectors are reshaped and updated, a little richer, a little more aware of their surroundings. By the time a vector reaches the top of the stack, it carries far more than the single word it started as. It carries content. So what happens inside a layer? The key idea is called self-attention. Every token gets to look back at the tokens before it and decide which ones matter to it right now. Picture the word blue. To make sense of it, blue reaches back across the sentence. It pulls hard on sky, because the two belong together. It pulls only a little on the words further back, like why. Those pulls are weights, a measure of relevance. And here is a clever twist. This looking around does not happen just once. It happens several times in parallel, side by side. This is called multi-head attention. Each head learns to notice a different kind of relationship. One head might track grammar, another might follow the topic, another might link a word back to what it refers to. Then all the heads report back, and their findings are merged into one updated vector. Many points of view, combined. After attention, there is one more step inside the layer. Each token's vector passes through a small feed-forward network. Think of it as a little refinement stage. It takes the vector, stretches it out, then squeezes it back down, nudging it into a more useful shape. Every token goes through its own copy of this, on its own. Then the vector is ready to move up to the next layer, and the whole process repeats. Eventually, the vectors reach the top of the stack. Now the model wants to predict the next token. To do that, it focuses on just one vector, the one sitting at the very last position. Why the last one? Because it has absorbed the whole sentence so far. And it is the natural place to ask, what comes next? That final vector is projected onto the entire vocabulary. The result is a raw score for every single token the model could possibly say next. Those raw scores are messy, so a step called Softmax tidies them up. It turns the scores into proper probabilities, a set of shares that all add up to 1. Now the model can read it like odds. Maybe because gets a high probability. Do and the get smaller slices. And here is the surprising part. The model does not always pick the top one. It samples from the distribution, sometimes choosing a less likely token. A setting called temperature controls how adventurous that choice is. So the model has now chosen one token, just one. And here is the heart of the whole thing. That chosen token is added to the end of the input. Then the entire pipeline runs again from the very start. Tokenize, embed, attend, project, sample. All of it, just to pick the next token. This is called the autoregressive loop. It is why the answer streams out to you one piece at a time instead of arriving all at once. Now, an important point. Every single pass through this network uses the exact same fixed numbers, called weights. Nothing is being learned during your chat. The model is not getting smarter as it answers you. All of that learning happened earlier, during training, long before you typed anything. Think of it like a river flowing over a riverbed. The water moves and changes, but the bed stays carved in place. So if the loop just keeps running, when does it stop? 2 ways. The model has a special token that means end of text. When it samples that token, it knows the answer is finished. Or it simply hits a length limit and stops there. Either way, the loop closes. The sequence of tokens freezes, and those tokens are turned back into readable words. That is the response appearing in your chat. So let's see the whole journey at once. Text becomes tokens. Tokens become vectors. Vectors flow through attention and feed forward layers, getting richer at every step. The last vector is projected into probabilities, and one token is picked. Then the loop runs again and again until the answer is done. ChatGPT does not dream up a reply all in one go. It predicts one token, adds it, and repeats. That is the click at the heart of it. Thank you for watching and for slowing down to look inside. I hope the next time words stream onto your screen, you can picture the loop quietly turning behind them.